Who takes or prescribes Viagra? Which heterocyclics does it contain? How do they affect its pharmacokinetics and pharmacodynamics? Those are some of the questions you'll be able to answer by the end of this topic. You should be able to identify the heterocyclics in different organic compounds, in different drugs, and predict how these heterocyclics affect the pharmacokinetics and pharmacodynamics of these drugs. Yes, same kind of guy. Please don't forget to subscribe, like the videos, and share. Also, a student should be well conversant with topics like molecular geometry, hybridization. If not so, you can check the description, the links are there, or you type molecular geometry or hybridization by MK the guy. The videos will be displayed. Here is what we are going to discuss. We want to know what are heterocyclics? Why do we need to study heterocyclics? The types of heterocyclics. Here we also talk about the Hako's rule, aromaticity, planarity, but we shall see the types. Then comparisons among different heterocyclic compounds, the structure, electron density, electron reactivity, nucleophilic reactivity, then the preferred position of electrophilic attack, which positions are more preferred than others. Then the ring stability, basicity of the heteroatoms, susceptibility to oxidation. How does stability helpful the stability of the heterocyclic rings? Then nomenclature, we shall talk about the monocyclic and mono-heteroatoms. Monocyclic ring and one heteroatom. Then monocyclic and multi-heteroatoms. Then we talk about the fused rings. These are more than one ring. We shall have one ring is benzene when both rings are heterocyclics in case they are two. Then we talk about the numbering of the whole system of the fused rings. Then reactions of the 5-membered and 6-membered heterocyclics, we shall talk about them. Then we go to synthesis, we talk about the Paulino synthesis and the Hirsch-Widman reactions. So all of these we shall discuss them in different videos, but we have to cover the whole topic. Let's go. Yes, what are heterocyclics? Heterocyclics These are cyclic organic compounds. They are cyclic organic compounds containing atoms other than carbon atoms. So containing one or more. So it can be one or more atoms other than carbon atoms in their ring structure. So heterocyclics, they are cyclic organic compounds containing atoms other than carbon atoms, can be one or more in their ring structures. So, for example, you can have this compound. This compound, this is carbon, 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 carbon. This is oxygen. You can have this. This is an heterocyclic compound. It is a ring structure having carbon atoms and another atom which is not a carbon atom, and many other examples. So why do we need to study heterocyclics? Why do we need to study heterocyclics? Many organic compounds, for example, drugs. When you look at different drugs, they contain heterocyclic rings in their structures. For example, when you talk about the beta-lactams, here we have penicillins, the cephalosporins, and others. For example, penicillin structure, this is the structure of penicillin. This is the general structure. So when you look at this structure, we have heterocyclics. This is carbon, carbon, carbon. This is nitrogen. This is sulfur. And this is one ring, and this is another ring. This is for penicillin. When you see cephalosporins, for cephalosporins, this is the structure. This is the basic structure. So these are heterocyclics. This is a 6-membered ring. This is a 5-membered ring. Now, other drugs, for example, the azoles, the antifungals, they have heterocyclics. So these heterocyclics, they determine the pharmacokinetics and pharmacodynamics. For example, in pharmacokinetics, the metabolism, absorption, also excretion, and distribution. Then pharmacodynamics, the receptor specificity. Here we can talk about the receptor specificity, and also the affinity of the drugs to their receptors, among others. So we need to study heterocyclics. Other than drugs, many organic compounds, many natural organic compounds, natural compounds. For example, the purines, pyrimidines, these are heterocyclics. When we talk about the pyrimidine, this structure, we have a nitrogen, this is a pyrimidine. It's a heterocyclic. It has carbon and nitrogens in its ring structure. When we talk about the purine, we have this. This is nitrogen, also nitrogen here, nitrogen, nitrogen. So this is a pyrimidine. This is a purine, this is a pyrimidine, this is a purine. And these ones, they are the basic structures for the DNA and RNAs. So we need to study heterocyclics. Other natural organic compounds, we have vitamins. B1, which is thiamine. When you look at its structure, it is having heterocyclics. Then we have hemoglobin. We have chlorophyll and many other natural organic compounds. So heterocyclics, they make approximately 2/3 of the natural organic compounds. 2/3 heterocyclics. So without heterocyclics, no life. So we need to study heterocyclics. Here we have hydrogen and hydrogen, but our concentration is on the heterocyclics.